Hello guys. Hello guys, this is Deepak. Today I want to share a project which is a complex project, which is medium to complex project. If you could replicate this project in your resume, you can get more hiring opportunities. Because this is an industry grade project, we have integrated some of the tools like Packer, Snake, Sonar Cloud, Trivi, JFrog. These are all industry grade tools, and we have also done an architecture using Terraform. Is usually called infrastructure as code. We have created this architecture using Terraform. It's gonna be interesting because we have also integrated Kubernetes, which is like container orchestration platform, because we have the Docker running out there. Uh, it's like a nature. We need to integrate Kubernetes because where there is a Docker, there is a Kubernetes. It's obvious. This gonna be interesting, and we'll go part by part. First part is the Packer, and second part is that this pipeline kind of thing, and third part is that Terraform. We'll integrate Terraform. We'll just write the infrastructure as code, and create all these public subnets, private subnets, secure subnet, and monitor using CloudWatch logs. And this application load balancer will give an something like DNS kind of thing, DNS kind of link, so that users can access. We can also do Route 53 if we want. Okay. And next thing is that we'll integrate EKS clusters, EKS clusters with the EKS clusters, and we are not going to use node groups kind of thing. We are going to use Fargate kind of things. If you know Fargate are like serverless nodes, serverless nodes, so that you can optimize the cost. That is the thing, and it is gonna be interesting because you have all this architecture at once. This is like a GOAT project. If you want to showcase in your resume, I think it helps. Yep, we'll get started into the part one. Yep, yep, the part one. Generating AMI using Packer. How could you generate, what is AMI? You may think like, what is this AMI? What is this Jenkins? What is this Packer? Okay, we'll say it. Yep. Why Packer? You may think like, what is Packer? Right? Did you remember this image? I think you remember this. This image rolls up whenever we create an instance, right? Absolutely. The main thing is that Amazon uses something like AMI to boot up an OS. You may think like, whenever instance is creating, the boot up time is very low. Like it is like 30 seconds or 40 seconds. Did you ever wonder in a 30 seconds, 40 seconds, how can you boot up an OS, right? The technology behind this is AMI. Amazon uses something like AMI images, Amazon images, in which in an image, in a pre-default image, this Amazon Linux and Mac OS or something like Ubuntu, these all images are been there pre-defaultly. And so that if our instance like a plain image, plain virtual machine, on the top of plain virtual machine, this AMI acts as a barrier, so that you can boot up this OS in like 30 seconds or 20 seconds. This is the technology behind this, booting up the OS and all the things at 20 seconds or 30 seconds. That's why downtime is very less at this Amazon images or something like that, using this technology. But okay, this is good. This is good because you're using Ubuntu or Mac OS operating systems at the virtual machine level. But okay, at industry level, you don't. You don't want only plain Ubuntu image or something like plain Windows image. You want something like custom AMIs, custom Amazon images, right? That's why Packer is important. See, Packer is important. That's why Packer is important. What does Packer do? Like Packer on the plain Ubuntu image, it will install something like it will create on the plain Ubuntu image, will create custom images. Like if you want to install something like SSM, something like CloudWatch or something like Docker on the top of the plain Ubuntu. Absolutely. That is called golden AMI. That is called golden AMI. On the plain AMI, we are integrating something like all the installations at once so that you'll understand. Wait, I'll show the practicals also. You will understand then like how we are integrating this plain Ubuntu image. On the top of it, we are doing like golden image, golden AMI. That's why it is so much important at the organization level, no, to use this workloads and all the things. You will understand all the things when I say when I do practicals. No need to worry now. Absolutely. And the next thing is that we need Packer to create AMIs. Absolutely. Great advantage of reducing downtime. Absolutely. The great advantage is that reducing downtime. As I said, the same technology is being used to create an instance and all the things. The AMI technology. Absolutely. And when we use auto scaling groups, okay, when we use auto scaling groups, your application need to be delivered fastly, like deployed fastly, and there will be there should be less downtime, so that we can use AMIs, our custom AMIs, so that that will be very much beneficial for the organization. Absolutely right. You are getting. Yes. The main thing is that you can use custom AMIs generated by this Packer. Okay. What does Packer do? Like Packer create a custom AMIs, which are mostly used in industry grade projects. Absolutely. That is why you need a Packer kind of thing. Without like, if we can also use user data if we want, but the downtime is very high because at user data you need to install whenever instance is launched. That's why it is not recommended as well. So that use Packer ka AMIs. Those are too much good, and custom AMIs. I mean, custom AMIs. Those are too good. So we'll go to next. Yep. Advantages of Packer. As I said, there are many advantages of Packer. You can create custom AMIs with using the Packer, and you can manage the workflows as well. Let's say you have something like a dev environment, prod environment, and something like test environment. These all things can be like you want to manage all these workflows across the environments. You want to create an AMI across this, so that Packer is a go-to tool. Packer is a go-to tool for this environments. You can just write a Packer file, Packer thing, Packer configurations at once, and just go and deploy in this dev environment, prod environment, and test environment. This is why Packer is being used. And next thing is that multi-cloud. As we said, uh, we can use in multi environments. We can use in multi-cloud too. Absolutely. That is the greatest advantage of Packer. With the help of Packer, we can deploy the things in multi-cloud also. We can manage the workflows at the multi-cloud also. This is the greatest advantage because at enterprise level, you don't need in enterprise level you don't use only AWS or only Azure. You use multi-cloud. It is hybrid cloud. That is why Packer is important. And next thing is that creation of customizable AMS according to project. Absolutely. Then next thing is that usage of AMIs will reduce the downtime of the application. As I said from a previous slides, the downtime will be reduced due to this usage of Packer and AMIs. Yeah. We'll get into practicals now. Okay, fine. We'll get into practicals. I posted in the LinkedIn also if you check this. Yep. This is the architecture and all the things. Yep. Let's get into this GitHub kind of thing. Yep. I created this something. I'll explain first the architecture kind of thing. Okay. How we'll integrate all the things. See. Yep. First thing is that Jenkins will get the code from GitHub, Git, Git, and just create the Packer AMI according to this something called files. We'll not use any AWS keys in this. We'll use something like, let's say we created this created in the EC2 instance of the AWS, so that and EC2 instance of this, so that we attached an IAM role to this Jenkins, to this instance as EC2 full access or something like that, so that Packer can create all the things. I'll explain one thing. Okay, this is the architecture of it. I'll explain in the practical way. You will understand how this is integrated. Okay, fine. This is a Jenkins file out there. There are no AWS keys here. We are not keeping any AWS keys here because there are many disadvantages and all the things. We are, even though we can keep here as an environmental variables or something like using with credentials with the Jenkins and all the things, but we are not keeping any AWS keys. We are attaching an IAM role to this EC2 instance where the Jenkins is running. This is the Packer ka file, Packer ka code. Basically, we are initializing the plugins. This is a plugin, HashiCorp ka plugin from the Amazon. And next thing is that I'm choosing this choosing this Amazon Linux as my AMI. On the top of Amazon Linux, I want to make an golden AMI, right? That is why this is the main goal of it. I want to make an golden AMI on the top of Amazon Linux AMI. Golden, oh, sorry, oh, yes. Next thing is that I'm making at the region of AP South 1, which is Mumbai. Absolutely, the latency will be very less. You need to take care of this latency part also because you cannot keep any East 1 or US East 2 because latency will be more because the distance is more. Absolutely. Then we can give any name according to us, according to project. And T2 micro is the instance type which we want to which we want to create with this the Packer image AMI is created. The source AMI will be like this thing. This is the Amazon Linux ka thing. Amazon Linux ka AMI part. Okay, I'll show you something. See here. Okay. Okay, fine. If you see here, wait 1 minute, it's loading. I think so. Okay. Fine. Fine. See here, Amazon Linux. You can find here AMI ID. The same AMI ID I have been used here. Nothing like you can these all the things you can find in the Packer documentation. Packer documentation is too good. If you want to refer, Packer documentation is too good. I have picked this from Packer documentation, and there's no rocket science or something like that. Something like that. Absolutely, you can pick it from Packer documentation. This is the thing I pick it from this thing. Amazon Linux ka image. Absolutely. SSH username, something like we can provide anything. AMI regions, absolutely. As I said, AP South one, we can't keep two different things here and here, region and here. Absolutely. This will pick up from provisioner.sh. We have created something like provisioner.sh. Yep. Here, if you see this, provisioner.sh, these are the things will be installed. These are the things will be in the sorry, in the AMI image. These are the things. First thing is that it updates the packages and something like it will install the Git is very much needed, and it will install SSM is like system manager, Amazon system manager, which is like, let's say you want to get into private private subnet instances. You want to access private subnet instances that doesn't have any something like public address or something like that, so you can't access directly via public address, so that you need uh, SSM, which is very much used. And CloudWatch, as I said, we will be monitoring using CloudWatch, so that we are installing this CloudWatch and AWS Inspector to troubleshoot and all the things. And Docker is our obvious thing, will be installed. Yep, yep. This is the thing. This is the thing. Let's see about this. Let's launch an image. As I said, we'll be not using any IAM things. Sorry, not IAM things. Not any keys in the Jenkins file. We'll be using using IAM role attached to this instance. Yeah, this is the thing. Packer AMI image. Yep, I already built it. I'll build it again. See, yep. It is okay. Fine. What does happen? Okay. Support support for password. Let's build it again. I think some issues there with this. Okay, some error came. Let's just create one project. Okay, fine. Pipeline. Packer का thing. Packer. Yep. Pipeline script. Git का thing. We'll just give GitHub का link. Oh shit. Yep. Credentials are none. Absolutely. We'll mention as main, as it is using main branch. Apply, save, something like build now. Yep, again, why the issue came? Okay, shit. Again, like I need to configure, I think so. Because Jenkins files is not found. I thought like this J is capital, right? Okay, fine, fine. Just the misconfigurations happened. Okay, fine, fine. Well, list. What's this? Okay. Yep. Yep. It is starting the checkout from the GitHub. We'll see the output, console output. See, it is validating the provisioner.sh. As I said, provisioner.sh will be validated first. Sorry, sorry. Okay. sorry, it will value, you will go to this thing, it will packer init packer execute. First it will check out this T2 micro and these things. Then validate this provisioner.sh. Provisioner.sh. In this provisioner.sh, you have all these things to be installed in an AMI. In an AMI, yep. See, running transactions. You need to know again, like what is the workflow of this packer. I'll explain now. First thing is that packer will create an instance. See here, there will be another instance running. See, another instance has been running T2 micro kind of thing, initializing in the with this sorry, with this EC2 instance, it will create an AMI out there. This is already created. I'm creating another AMI so that it will create another AMI using this instance running, right? T2 micro cutting. It will create using this instance. Whenever this AMI is created, whenever this AMI is created, automatically this instance will be deleted or terminated. That is the use of packer. You can't manually create this Amazon images, right? Custom images. That is why packer is being used. That is why packer is being used. See, it is running state. See, again, stopping. It is stopping. Again, here, like another AMI will be rolled up. Whenever this is terminated, here AMI is automatically rolled up. That is the beauty of packer. See here, it is stopped. It will be terminated. See, here the another image is there. Pending. It is in pending state. It will be terminated according to it. Yep. It is in still pending state. A second after the status will be available, this instance out there will be terminated. See here, it is stopped again. Yep, it's still pending. Yep, as I said, the process is continuing. See how much. See here, stopping the source instance, stopping the instance, creating the AMI ID, and waiting for AMI to be ready. As I said, I already created this all the things. You can follow my LinkedIn if you want more projects. And these are the GitHub links. Let's see if the if this instance is terminated or something like that. I said that something like I created an IAM role for the instance, right? If you see here, this is a Kubernetes instance running where the Jenkins server is also running. See, if you see here, sorry, actions, you can see sorry, security, modify IAM role. See, I've attached something like AWS project, which has something like IAM, IAM roles. Wait, not roles, right? See here, AWS project. It has something like AWS project. See, it has administrator access. It can do anything. Like I have attached it directly, and I am rolled to the instance level. So that instance, let's say, uh, Packer will push and request to this Jenkins, so that Jenkins is hosted on the instance level, so that the instance automatically creates this Packer AMI according to the process. Like it will create an instance and destroy the instance and all the things. Let's see if this thing. Okay, fine. Let's keep this here. Okay, fine. If you see here, yep, I think so. Yep, success. Let's keep this here. Yep, you can see here success. It's been successfully. I'll say it's startingly created an instance. As I said, it will create an instance and create an instance. Using that instance, it will create an AMI. Creating an AMI, absolutely. Waiting for AMI to be ready, skipping the AMI deprecation and terminating the source instance. First thing is that at a Packer level, it will create an AWS EC2 instance. Using that instance, it will create an AMI. After creation of AMI, it will just, sorry, at a parallel process, it will create the AMI and also terminate the EC2 instance also. It is important to destroy this EC2 instance also. The Packer take cares of all the things. That's why Packer is being important. If you want to try out, absolutely you can try out. There is a GitHub link also, but don't just copy paste things. Okay, you just understand these things, like why I'm installing this Packer on all the things, so that it will be beneficial, and like, you can also tell in your interviews. Yep. First part is successfully completed. We have many parts coming up. We'll see it. You may think like why this Packer is how this Packer is used in this project. Yep. If you see here, 1 minute. Yep. If you see here, this Packer is used in the part three again. Using the Terraform, like will attach this AMI Amazon like customer. This is golden AMI to this auto scaling group, so that you can reduce the downtime. As I said, absolutely. First part is been completed. Let's get into second part. Okay, fine. This is the second part. Scanning for vulnerabilities, generating jar file and push to Docker Hub and JFrog. In the architecture, okay, fine. This is a second pipeline because we integrated Packer to the first pipeline, and this is isolated from each other. This second pipeline. In the second pipeline, we'll fetch the code from the GitHub. GitHub will use an good project, because a good Java project, which is like 10,000 lines of code, 10,000 lines of code, which is very good. And uh, we'll also integrate something like DevSecOps tools like Snake, Sonar Cloud, Trevi, and something like JFrog also. JFrog is also very good tool to integrate it. If you see here, we have integrated Snake, Sonar Cloud, Trevi. This Snake and Sonar Cloud will scan for vulnerabilities in the code, and Trevi will scan for something like what to say. Trevi will scan the Docker. Docker file, vulnerabilities in the Docker file. You can also use Docker Scout also. I think so. Docker Scout is also coming up, and something like you can also use Snake here again if you want. But I have integrated Tree for my purpose. You can also integrate something like Docker Scout, something like Snicker Docker, and everything like that. Absolutely, it is recommended to do like that. Yep. This is a workflow of it. Yep. First thing is that we integrate Snake, Sonar Cloud. Sonar Cloud. Snake has plugin in the Jenkins so that it becomes easy for us. And Sonar Cloud we don't integrate with Jenkins, but I have done some architecture error, something like that. We'll integrate directly from Git so that whenever a change occurs in the Git, automatically Sonar Cloud will fetch the information and just scan for the vulnerabilities and just send the notification to our mail or something like that. And yep, these things are DevSecOps approaches, like those things. And next thing is that absolutely. Whenever we are dealing with Java application, it is recommended. It is like the mandatory approach to build the jar file. Jar file will just write a command called mn clean package and something like that. Here, let's say there are vulnerabilities, so that we'll skip some tests on all the things, so that these vulnerabilities don't affect this step step in the Maven build in the Jenkins. Yep. The next thing is that using this jar file, we'll build a will containerize this application. Will containerize this application. Next thing is that scanning for vulnerabilities in the containerized application in the Docker file. I mean to say. Next thing is that pushing the jar file. Absolutely, it is industry grade tool. JFrog is industry. It is a go tool because go-to tool. It is like to store any jar file. It is a go-to tool because you have something like JFrog X-rays in which you can scan for vulnerabilities and all the things. It is not recommended to store this all the things in Docker Hub. The jar file and all the things, because in the Docker Hub I think so there is more piracy and all the things, so that industry don't prefer to store in the Docker Hub, but still we push the Docker images into Docker Hub and the jar image to JFrog. You can learn JFrog. Absolutely, it is recommended to learn this JFrog thing, how to integrate on all the things. Absolutely. I think you understood this workflow. Yep. We'll get into this code. As I said, I have LinkedIn thing. You can like, if you like this video, and just comment it out and tag me. Yep. This is the thing we are forking from something like Spring Pet Clinic, which is like mostly used in the presentations of the industry grade. It has something like 10,000 lines of code. As I said, it is very big project. We are deploying this only at our project. Yep, this is a project file, and yep, have added something like a Jenkins file. We'll look into it. Yep, this is the thing. Okay, yep, the pipeline part. Yep, absolutely. We integrated something like tools like JFrog CLI. You can get it from your Jenkins only. Like you need to install some of the plugins. I'll say go to manage Jenkins, get into plugins. Okay, I already installed it, but install it. First thing is that JFrog. Sorry, I need to. Okay, fine. JFrog. Yep, this is a JFrog plugin, JFrog official plugin. We are using the JFrog, so that it is recommended to use this JFrog plugin. Next thing is that Snick plugin. See, again, Snick is there. Absolutely, you can read if you want about this, how to integrate and all the things are there here. This is official documentation from Snick. You can check it out. Install the Snick plugin, configure the Slick plugin, and all the things. Yep. Go according to this thing. See, do all the things according to this. I not done any rocket science. This is not any rocket science. I just took this from documentation, official documentation. So there is no worries about this. And next plugin is that I think so. Yep. If you want, I think Maven ka plugin. Yep. Maven integration plugin, something like snapshot clicking plugin, and something like that. You can do it if you want to just use Docker as a Docker agent. Take this Docker pipeline plugin also. This is also good. Absolutely. This is also good. Where is this? Okay, fine. Yep. Really, yes, yes, Docker push, RT, build, yep. These are the things I'll explain once, like what is the Jenkins file. Jenkins file I have created. Yep. This is the thing. As I said, we are using JFrog. I have integrated tools like JFrog. Uh, to get this tool, I think we need to go to manage Jenkins tools. I'll say about tools now. Okay, fine. We'll go one by one. See here. First thing is the JFrog CLI. As I said, we'll use JFrog CLI. Take exact name from it. JFrog CLI. Absolutely, JFrog CLI. You can do as install automatically. Absolutely, install automatically. Next thing is that snick. Sorry, we assume that sync as an Indian mentality or something like that. Accent. It is snick. I think it's snick. Okay, that is the thing. Okay, fine. Uh, I have copied this from official documentation. Absolutely, you can integrate this Snick installations, Snick at the rate latest. You can, if you want anything like auto detection or something like that, you can install the latest version as possible. Update policy interval has. You want to update within the 24 hours time span. It is good to have that. Absolutely, the two things are done. Next thing is that Git. Git is absolutely required. If you, yes, you can do this Maven cutting also. I did not install used the declarative tool at the Maven because I have installed in the EC2 instance. At the EC2 instance level, I have installed this Maven and packer cutting. So I need not to do this declarative tool install again and again because Maven build are like is all the things you can do this if you want, but I don't recommend this from the declarative tool because it's a mandatory thing. Yep, you can store the credentials and all the things in this credentials thing. Absolutely, we have Sonar Cloud ka token, Sync API token, Sonar Auth token, Docker credentials. You can have JFrog ka CLI, uh, JFrog CLI ka credentials. These are my credentials. I'll delete it after this tutorial. No worries. If you may see it or not, no worries. These are the tools or technologies we have been using. Yep. First stage is that scanning, snick scan. Sorry for my error. Okay, fine. This is the thing I have just copy pasted from this documentation. There is no rocket science, as I said, Snakes. Absolutely, you can refer this documentation if you want. Absolutely, you have all the troubleshooting and all the things hit here. Absolutely, official documentations are go to tools, go to things if you want to get into this DevOps and all the things side. Absolutely. This is the thing, and as we have configured according to this Snick latest. Snick latest is the name we have given in the tool. Absolutely, we are using Snick API token. Absolutely, you can generate an API token from the Snick. Snick website. I'll show you the Snick website. Absolutely, Snick using GitHub. Sorry, okay. See here. You can see there is a nice dashboard out there. You can see what are the vulnerabilities and all the things. You can raise a Jira ticket according to it. See, these are the dependencies. See, this is a big project, right? That's why this many things are being showed up. Absolutely. Created by Deepak and all the things. Yep, this is the thing. You can generate all the API tokens if you want. Yep. Monitor on build. Yep. False. Fail on issues. False. Because if a pipeline fails on issues, it will not go forward, right? That's why I have done this fail on issues false. Additional arguments. You can generate you can forward this all these vulnerabilities at all vulnerabilities.json file. It will be very good if you open that file and just raise a Jira ticket to the developers so that vulnerabilities will be resolved. This is the first stage, snake scan. Next thing is that we are building an artifact. You can see like this. You can see this. This is confusing, right? Absolutely. I'll say about it. This is the thing. First, we need to create an jar file. Sorry, we need to generate a jar file with the help of maven, so that this is the command maven clean package. Okay, this is good, but you may think what all are this is the thing. Okay, these are the things. D skip test equal to true means, let's say this thing have like 10,000 lines of code. As I said, you have something like 15 to 20 tests. It may take up to 20 minutes of time to do all the tests. So it is just waste of time to do all the tests. So that I have skipped this all the tests. And next thing is that the check style skip. Absolutely, we need to skip all these issues out there. Let's say if we take these issues, uh, if we take these issues forward to this stage, so that this stage may fail. That's why I have done this text check style is equal to skip and minus fn. Minus fn means something like build failures. Ignore the build failures because every time we run something or something happens. Okay, that is why we ignore this. And this is the thing. Shell script. Sorry, shell command. This builds a jar file, gives us jar file. According to jar file, we can create all the Docker files and all the things. Yep. I'll explain this later. I'll explain this later. This is simple. No worries. This simple thing. We are integrating JFrog to it. We are configuring JFrog using this. I'll say about it. No worries. We'll see about it later. Okay, fine. Next thing is the Trivi FS scan. FS means file system. It is very needed to scan the file system so that any vulnerabilities are identified and can be raised in Jira ticket or something like ticket to resolve it. That's why I scanned using Trivi, which is a go-to tool. Go-to tool in this workflow. Absolutely, the step is first thing is that uh, Trivi fs.fs. Yep. We are redirecting to Trivi fs.txt so that we can view this Trivi fs.txt. Yep. Next thing is that building a Docker image. We are building a Docker image. According to the Docker file, I'll show the Docker file. Yep, this is our Docker file. We are using OpenJDK 22. Absolutely, whenever building Java file, Maven Java file, it is needed to have JDK or something like that. That's why we are using this thing, JDK as a base image. We are not using any Ubuntu or something like that as a base image, because you don't need Ubuntu as a base image here. You need JDK or Maven, some kind of things like that, so that this application runs smoothly. Yes, the work directory is home pet clinic. Absolutely, we are assuming that home pet clinic is the work directory. Absolutely. Yep. The jar file is created here. We are copying it to this work directory out there. We're copying this jar file to this work directory. We are exposing it port 8080. It's the go-to tool of this Spring Boot application. So that we are exposing this 8080, and we have absolutely, that is the uh, port of this application, and we are yep, we are running this jar file, executing this jar file using this Docker file. And this Docker file pretty simple. This is pretty simple. As I said, you can write in 2 minutes if you have enough knowledge of Docker. Yep, this is a Docker file. Yep, yep. You build a Docker image. Then next step is that scanning the Docker image, right? Yep. Using the Trivy as a go-to tool, we'll scan the image out there. This is the image we build it, and now we are scanning it. And if any vulnerabilities are reported, we'll be just redirect to this txt file, so that we can see the vulnerabilities and raise a Jira ticket according to that. Absolutely. The next thing is that uh, Docker image push. We are pushing an Docker image, so that we can use from the Docker Hub out there with the credentials. As I said, I have configured the Docker credentials. The name of this is Docker Cred. Yep, if you want to see it, I'll not show the credentials, man. Okay, see here, like, yep, this is a Docker Cred. The name is same. You can see that. Maintain the same name, right? You can't. You will face an errors while doing this. Make sure that there are same names according to that credentials. Yep. The simple command, the shell script command, docker push, build number, something like that. Yep. The same thing. Okay. Now comes a JFrog file. I need to explain this also. I'll first open this JFrog thing, so that you can see how I integrated JFrog. Yep. This is the URL of it. I kept something random name, CNCF or something like. They have given options for me to choose the company, so that I have put random name CNCF. CNCF is like, I contribute to the CNCF fold, so that I just kept that name. Okay, 1 minute. I think I need not to log in through GitHub, because GitHub is not my go-to tool. Yeah, already credentials are in there. Yep. Yep, this is the thing I created around like 2 days ago. I think so. Yep. That is why I'm using free trial version. This is paid, yeah. JFrog is paid, and yep, that is the thing. Here, if you see like artifacts, I created new artifact Maven remote thing. Maven remote thing. It will create four things: Maven remote release, Maven remote lips snapshot, something like these four things are being created here, and even artifact build info is also been created. These four things I have configured here. If you see here, yep. Maven config repo resolve releases. See here, Maven remote release, Maven remote lips release, as I said. Sorry, Maven remote lips release, Maven remote lips snapshot. See here, Maven remote lips snapshot, Maven remote lips release local. See here, and remote lips release local. Yep, snapshot local. Snapshot local. Absolutely, there is no lock extension here. You can just get it from this official JFrog documentation. I have used I have used maximum JFrog documentation, maximum from official documentation only, maximum tools from official documentation only. No worries. So that this is the thing. Yep, I just configured these things through Jenkins so that it will just pass the all the build info and all the things. Here only we'll just push this jar file. Sorry, jar file. In this artifact only we'll just push the jar file so that it will be stored, so that I configured those things. There is no rocket science in that. Yep, I created this jar file. Okay, fine. Yep, yep. Next thing is that build the publish info. It is not mandatory, but just for a show kind of thing, I just publish this build info so that you can just watch this all the things. Here you can see artifact build info. Absolutely, this is a build info and all the things. Builds. Yep, here you can see artifact build info, build number 75 and all the things. Yep, this is not mandatory, but if you can keep, this is good. Yep. Next thing is that pushing the artifact. Absolutely, we will push this jar file into this. This is a command out there to push this jar file. First thing is that JF will be using JFrog ka plugin. JF is something like usage keyword, so that you can use JFrog CLI to authenticate to this. We have just uh, gave these credentials to the of the JFrog so that it will just validate and give the output. We'll use JFrog cutting, GF cutting. Yep. RT, absolutely. It will just upload, you means upload. It will just upload this jar file out there. This is a path of jar file. This is the source. The first thing is that source. Second thing is that something like target. It will upload this jar file to this. It will upload this jar file to this target out there. That is why this is being used. Uh, this is a where live Jenkins workspace. From the workspace, we'll just pick this snapshot dot jar. If you see here, 1 minute, I build it. Dashboard, pipeline part 2. You see here, okay, workspaces. You see here, there is a target file out there. Your target file out there. In the target file, you can see successfully see like Spring Pet Clinic 3.2, 3.2, 2.2 snapshot jar. It will push this jar file to this thing, this JFrog thing. Here you can see the what to say, the path of this. Maven remote live snapshot local. Here, if you see artifacts, Maven remote live snapshot local. Absolutely, we'll go into this path. Here, if you see com example, Spring Pet Clinic 3.2.20 snapshot. Here you can see jar file. Yep, this is the thing. It done exactly what we specified. Com example Spring Pet Clinic. You can just ignore this if you want. Just push directly the jar file. I just done for random reason. Yep, that is the thing. First thing is that source. Second thing is the target, where to push and all the things. First, you need to create this artifact first. Then the push. Then you push this jar file. It will be good. Yep, this is the thing. I think you have understood this Jenkins file. Let's just for a demo thing. Let's build this pipeline. Okay. First, declarative tool install. It will install JFrog CLI, Snick scan. See, you can see like testing the project, generating the report, result. See, 91 dependencies, 7 non vulnerabilities, and all the things. Here you can see like these are configured. MVN like in the JFrog it is successfully configured. And next is that building the jar file, scanning for projects. Absolutely build success. A jar file has been created. Next thing is that file system scan. File system scan using tree. Yep. Vulnerability scanning enabled. It will just scan and redirect to this tree text. Absolutely. Next step is Docker build. We'll just build this Docker image. Yep. Next thing is a Docker image scan. We have scanned this file system first. Tree file system scan. Next thing is a image scan. Docker image scan. It will scan. It will take some time, I think so. Yep. Tree 37 seconds. Yep. Docker push. Yep. It is using catchy from it because I have pushed it multiple times so that it is just using the catchy out there. Yep. It is publishing the build info. See here, build info. Absolutely. Next thing is that pushing the artifact to the JFrog. See, success. Successfully completed the second part also. This is the thing you need to do. See here, 25th, something like created, last modified, 25th, 15, 7. Yep. Push it successfully do this. What is the advantage of, you may think, what is the advantage of JFrog? You can see like all the vulnerabilities in the JFrog, in the jar file. This is called X-ray, JFrog X-ray, in which you can see everything. You can just play with the jar file out there. That is the advantage of this JFrog kind of thing. Absolutely, it is too good to have JFrog. Where is this? Okay. Yep, you can see like successfully pushed this jar file to this JFrog and to this desired path. I think you have understood all the things. I'll show this snake report also. Yep. This is a thing, snake test report. You can see all the things like seven known vulnerabilities and seven vulnerability dependency paths and 91 dependencies. You can just raise a Jira ticket uh, to the vulnerabilities out there. And we have, yep, this is the thing. This is the thing. See here. And all the vulnerabilities are there. You can just more about this vulnerabilities and all the things. You can see all the vulnerabilities and just raise a Jira ticket according to them. You can see artifact build info also. Yep, this is also okay. Fine. This is also okay. Yep. Next thing is that in the workspace section, you can see this trivia test cover vulnerabilities. See here. Okay, fine. This is something encrypted. I think so. Yep. Here you can say total 502, unknown one, low 378, medium 551, high 82, critical 10. You can just raise a Jira ticket according to them. According to them, you can see file system scan also. This is also okay. You can see all vulnerabilities.json. In the all vulnerabilities.json, you can see all the vulnerabilities which are being generated by the snick scan. You can see like snick Java, choose back, something like that. Okay. This is the thing. You can just read. JSON is pretty readable, right? That is why you can read it and just raise a Jira ticket according to it. Okay, this is the thing. This is the second part. I think you liked it. If you stay up to here, this is too good. Yep. Yep. 1 minute. Yeah. Yep. I'll come back. Okay. Fine. Let's get into part three. Part three. Okay. Part three. Creating infrastructure for three-tier app using Terraform. This is more interesting kind of thing. Yep. You'll find this interesting. Absolutely. Because we are creating an infrastructure using Terraform. I'll explain this kind of thing. Okay. I'm somewhat okay. Here, if you see, we have internet gateway. In an internet gateway, we have two public subnets, two private subnets, and two secure subnets. You'll know secure subnets later, okay? Fine. In a private subnet, in a VPC, we have these things. In a private subnet, we have created two NAT gateways, right? We have you need to know between created and associating route table also. Like what is the difference between them? We have created two gateways in two private subnets, and we have associated route table from private subnet to NAT gateways. From private subnet to NAT gateways. From private subnet to NAT gateways. To NAT gateways. That is the thing. In the private subnet, we have auto scaling group, which automatically rolls up EC2 instances, two EC2 instances with the custom AMI. As I said, we have created our custom AMI. Using that custom AMI, automatically the instance are rolled up. We also integrated something like user data.sh. In that, we'll just use the user data so that instances are automatically rolled up. rolled up and Docker image is successfully running. That is the thing. Absolutely. You may think why NAT gateway is being integrated. NAT gateway is something like, let's say, NAT gateway depends on internet gateway. How means, let's say there is a public subnet, and you need to download a package from outside the world, so that let's say it is a private subnet, right? You want to download from the outside the world. So from the internet gateway directly request go to outside, and it will just fetch back the packets. uh, in this process, there is IP address of the private subnet will be compromised. I mean to say, IP address will be exposed to the outside world. This is not a good practice. This is not a good practice. So that what NAT gateway does is that NAT gateway does masking of this IP address of the private subnet. In the private subnet, it does mask the IP address and just give request to the internet gateway, and through the internet gateway the packets are being downloaded, and the IP address compromisation will be not take place. That's why NAT gateways are being used. And the next thing, and the one more thing is that in the private subnet we integrated two NAT gateways, right? With this NAT gateways, absolutely we need to integrate elastic IP addresses. For each NAT gateways, we'll have something like elastic IP addresses. That is why elastic IP address for each NAT gateway, there is each elastic IP addresses. Okay, that is the thing. We created two NAT gateways and two private subnets. We created an auto scaling group in associated with two private subnets, and two absolutely will auto scaling group will take care of instances and all the things. Yep. In the public subnet, you can also see application load balancer. Absolutely, we need to keep this application load balancer in the public subnet so that users out there can access using application load balancer ka DNS link. That is why it is important to just put this application load balancer in public subnet. Absolutely. The next thing is that private subnet also, uh, yep, in the through these private subnets we have associated two route tables to this NAT gateways. One route First route table is from the instance to this private subnet to public subnet NAT gateway. What to say, this private subnet to NAT gateway. We have two separate route tables out there. We have And in the public subnet you have one route table directly associated to internet gateway. That is the thing. You have two route tables here, different route tables associated with NAT gateway, and one route table directly associated to internet gateway in the public subnet. In the private subnet, two different. Absolutely, that is the thing of this thing. And we have two availability zones. As I said, we don't have any one availability zone. This is most recommended by the AWS also, to have two availability zones. This is an I think so, AP South 1 and AP South 1A and AP South 1B. That is the thing. You can do any other things also, any other region also if you want. That is why we are using two availability zones to have maximum application, like to say what is a maximum application efficiency. That is why you have two availability zones. And next thing is that you may think what this is new, like secure subnet. Absolutely. You may think, what is secure subnet, Deepak? I have never read about it, and I have never read and just what to say done this secure subnet thing. Can you explain me this? Yeah, absolutely, I can explain it. This is secure subnet. In this secure subnet, you don't attach any route table to this internet gateway, whether it's NAT gateway. You don't attach any route table to this. Okay, you may have doubt like you may have doubt like, if you don't attach this route table, how can you just attach this auto scaling group to this RDS instance out there? How can you do that, right? Absolutely. Through auto scaling group and through this RDS endpoint, we'll attach this auto scaling group. That is the thing. We don't attach any route table or all the things. We'll just attach this RDS endpoint. RDS instance, every instance have RDS endpoint. That is why we are integrating this RDS endpoint to this auto scaling group. That is the thing. That is the thing. We are using secure subnet, and in the secure subnet, there is no port open and there is no things. If you want, sorry. In the secure subnet, I think some database support is open. That's it. And nothing is open, and there is no route table associated with it, and there is no NAT gateway in the secure subnet, and all the things are not there because database is the most uh, is the most secure part. You need to secure it. Let's say if you have application and you just expose it in the private subnet or public subnet, the database part in the public subnet or private subnet, and you open the ports and associated route tables and all the things, it is highly high chance that hackers will hack your database and get your information. That is not good. So that we are integrating in a secure subnet. It is very much important to do in the secure subnet kind of thing. Will not attach any route tables and all the things, and in the private subnet also will not open any ports. Will not open any ports. Absolutely will not open any ports like 22 or something like that. Okay, you may have doubt like, if you don't open the port, how can it troubleshoot the application, right? Absolutely, you will get that out. Absolutely, we'll use something like AWS SSM. SSM means system manager. Using that, you can just connect to this private subnet in which there is no public IP address, so that with this SSM, AWS SSM, you can connect to this private subnets, so that you can easily troubleshoot these applications. That is the use of AWS SSM. Absolutely. The next thing is that uh, if, auto scaling group will take care of all these instances. Like, if if these instances get down, automatically another instance will rolled up. Yep, this is the thing. 1 minute. Okay, fine. This is the thing. And using application load balancer IP address. Sorry, what is the thing? DNS DNS address. Using this address will just access the application. That is the kind of thing. We'll discuss the Kubernetes part in the next part 4. For now, we'll discuss this part 3. Yep. This is the part 3, creating infrastructure for 3-tier application using Terraform. We'll just get into it. The GitHub link. These are mines only, no worries. Yep, these are the things there. We'll just open in a code space. I already created it. Yep, this is the thing. Let's just open it. Yep, it is setting up. I have not used it VS Code kind of thing. Have used it this code space only. I'll explain all the things here. Yep. Starting from this thing. Yes. Starting from this resource kind of thing. First thing is that we'll create create this AWS VPC, my VPC. I just gave a random name. Okay, this is the thing, and CIDR block. Sorry, will just pull that CIDR block from this variable. You can see the CIDR block. It has something like 65,000, something like that IPs. This is the thing. We'll just pull this CIDR. Uh, where is this main file? Okay, yep, yep. This is the main file. You can see like from that we'll pull this. But not pulling. Like we're calling this variable CIDR. CIDR variable enable DNS true. We are just enabling this DNS so that it will be useful at load balancer kind of thing, host names and all the things. And this is a tag and the name of this AWS three-tier application. As I said, we'll create two public subnets, two private subnets, two secure subnets. That is the thing. That is the code of the two public subnets. Sorry. Here you can see map public IP on launch. If the public IP is there, that is a public subnet. That is why we are using public subnet. These are two public subnets. This is, you may think these are complex like that. Just go to Terraform documentation. Sorry, 1 minute. Terraform docs. See, here you will find everything like Terraform docs for, sorry, docs for AWS. This is the official documentation with the AWS kind of thing. Wait, it's loading. Here, just filter out. Let's say you want public subnet. Okay, just pull out something like subnet. Here you can find everything like subnet. Okay, this is okay. See here, AWS subnet. See the same thing I have created. Look, this is a VPC I have created. Oh, sorry, this is the subnet, public subnet I have created. This is the thing. From this only I created. There is no rocket science or something like that. Something like that. I have created from this official documentation only. No worries, no worries, no chinta or no something. Absolutely, I have created from this official documentation. You also refer this official documentation for a creation of these things. Absolutely, this is also I created for this so that you refer the official documentation. Absolutely. These are two public subnets I have created. I have just gave an option called public IP on launch equal to true. You can see two availability zones, South 1A, South 1B. Yep. The next thing is that we are creating an internet gateway. It is important to create an internet gateway. Here, if you see that, 1 minute. See here, internet gateway has been created. First, we created an VPC. Inside that, we created two public subnets. Okay, in our if the VPC, we associated internet gateway. Yep, successfully created. Next thing is that route table. We are creating an route table to the internet gateway. See here, if you see here, okay, fine. If you see here, from the public subnets, two public subnets, we are associating a route table to internet gateway so that an ad gateway or something like that can access the internet. It is very much important to associate the internet gateway. Yep. We are associating the internet gateway and route table. See here, this is a resource for route table association to the subnets. We have two subnets, right? Here we created internet gateway. Here we created route table. We are associating route table to this two subnets. Two subnets. We have specific blocks for this resource route table association. Subnet ID, route table ID. Subnet ID, route table ID. That's it. This is very simple. There's nowhere complicated or something like that. Okay. Next thing is that it is a essential. It is not mandatory, but okay. I have just created an security group. Security group. Security group at the VPC level. If you see here at the VPC level, I mean at the public subnet, you can see 80 and 22 are open at the public subnet, so there is no worries or something. Hello guys, let's resume from this thing. Okay, fine. As I said, we created a VPC. In the VPC, you have something like two public subnets, two public subnets. These are two public subnets, and something like internet gateway. Here you can see like, okay, we'll just maximize it. Absolutely, internet gateway to public subnets and NAT gateways. We'll see it. Where is this? Okay. Yep. Here you can see internet gateway. You have route table associated to the internet gateway from the public subnet to internet gateway. There is a route table so that you have route to the connection between this internet gateway and public subnets. Here is the resource for associating route table to the public subnet. These are two individual subnets. Here you can see subnet 1, subnet 2. We associated a route table to this subnet 1 and subnet 2. This is the resource of it. And next thing is that we have integrated security group to it. Absolutely. It is not mandatory or something like that. You can skip it if you want. Just comment it out or something like that. Yep, you can comment it out if you want. Absolutely. The next thing is that here, if you see that uh, there are two NAT gateways. For two NAT gateways, there is some like condition before that. For every NAT gateway, we need to associate an elastic IP address. I mean to say elastic IP address means it doesn't change. IP address doesn't change. The IP address remains same. So that we need to associate two for each NAT gateway each elastic IP address. That is mandatory thing. We need to do it. We need to do it to get the NAT gateway thing. Where is this? Yep. NAT gateway thing. Absolutely. Elastic IP address. We associated elastic IP address. See, you can see domain VPC. We'll associate later. We first create this elastic IP addresses. These are two elastic IP address. First thing is that we'll create this elastic IP address. Next thing is that creation of NAT gateway using this elastic IP addresses. Here you can see allocation ID, elastic IP address, elastic AWS EIP dot EIP for NAT gateway one. We are creating first NAT gateway dot ID. We'll just fetch this ID, and next thing is a subnet. We are creating in a public subnet. Absolutely right. We are creating this two things in public subnet, two NAT gateways in a public subnet. That is why we are using this public subnet kind of. Let me just put this here. Okay, fine. This is the thing. Uh, we have created two NAT gateways. Z1, Z2. Just order difference. Okay. Sorry. Here, if you see two NAT gateways, AZ1, AZ2. These are two NAT gateways, two elastic IPs, two NAT gateways, two elastic IPs. This is the thing. Yep. This is the thing we created in the public subnet. We have two public subnets, one internet gateway, one route table associated to this two public subnets, and two route table association. We need to associate this route table to this public subnets, right? That is why you use two route table association, one security group out. This is the thing up to now we did. Next thing is that, okay, okay. Next thing is that we have two elastic IPs, two elastic IPs. With these two elastic IPs, we integrated with two NAT gateways. Okay, NAT gateways. This is the thing up to now we did. Okay, I think you can clearly see from here. Next, next thing is that we need to create two private subnets. Two private subnets. In that private subnet, we need to create auto scaling group. Okay, we'll get into auto scaling group later, but we'll create two private subnets right now. Let's create. We need to also associate route table to it. Absolutely right. We need to get uh, we need to create two private subnets and associate route table to NAT gateways. NAT gateways. Associate route table to NAT gateways so that masking happens, like IP address masking happens properly. That is the thing. We need to create two NAT gateways, two route tables. See here, we need to create two public private subnets, two route tables, two different route tables, two associations. We need to associate two means totally in this block we create six resources, right? Two public private subnets, two something like two route tables, two association to the route table or something like that. Oh wait, okay, fine. I think six resources. Here, if you see, private subnet one, private subnet two, we created. Here, if you see, map public IP on false. This is the thing, like difference between the private and public subnet. You can't get a public IP in the private subnet. Here, if you see, it is true. Map public IP on true in the public subnet. But here in private subnet, it's false. You can't get any public IP for this. We created two private subnets, and absolutely we'll just create two route tables. As I said, two route tables. These are two route tables we create, and we associate route for the route table NAT gateway. As I said, we'll associate NAT gateway to these route tables. And next thing is that association. We associate uh, private subnets with the route table. Associate private subnet with the route table. You can see here. It's not a big thing. It's pretty easy. I think so. Yeah. For now, this block is completed. Like first block has been completed. Second block has been completed. We'll get into auto scaling group and application load balancer. We'll just create. We'll just know about it. And next thing is that we need to create secure subnet. We'll get into it. Okay. And where is this? Okay. We just associated this. Okay, leave this. Up to this we completed all the things. I think you have understood all the things how this works. how the infrastructure as code works. Absolutely right. Yep. Yep. The next thing is that secure subnets. We need to create two secure subnets. If you see here, we'll create two secure subnets, same like private subnets, map IP on false. The difference between secure subnets and this private subnet is that we don't associate any route table to this. See, here we created only this secure subnets. We have not associated any route table to this secure subnet. That is the difference between private subnet and secure subnet. If we associate the route table to this, it is very easy to hack. Like let's say uh, here in the secure subnet we'll store a database, right? If the database is information is compromised, it is like organizational loss, so that we are not integrating any route table to it. That is the difference between secure subnet and private subnet. I think you have understood the difference between that. Uh let's go to thing. Okay, fine. Yep. Absolutely, we created two public subnets, two NAT gateways, private subnets, two private subnets, NAT gateways, route tables, and everything, two secure subnets, and all the things. Route tables are also associated to it. Here is main thing comes, like first thing is the application load balancer, auto scaling group, RDS clusters. RDS clusters or RDS instances. We'll be creating RDS instances rather than RDS clusters because it's not like a bigger application. If you want, you can create RDS clusters, no worries. Yep. We'll get into it. First thing is that application load balancer. Here you can see application load balancer. Yep. Here's the configuration. No worries. You can always get this template from Terraform documentation. There is no worries. Okay. You not need not to worry like how you written all these things. I have not written completely. I have written from GitHub Copilot, something like Terraform documentation. That is why it's pretty good. Even the DevOps engineer don't write complete things. Pick up from documentation or something like that. That is a good approach, even though. Yep. Let's look into application load balancer, ALB kind of thing. Yep. First thing is that, yep, this is the thing. Application load balancer. We are creating an application load balancer. Internal halls, application a load balancer type application. As I said, we'll create application load balancer rather than there are many kinds of load balancers, but we are creating only application load balancers. Absolutely. We are we need to create one security group for this application load balancer also. Here is the security group. Where is this? Yep. See here. Here is the security group. Uh, I have access to this ports like port 80, 443. We'll know about port 80 and port 443. 443 for HTTPS access. HTTPS means hypertext protocol something. With the security also, if we can integrate TLS or SLS certificates also, we can use this port 443 and 80, and application is running on port 80, so that we integrated port 80. And this application load balancer is on public subnet, so we can access we can you can expose any ports as many as you want, because it is a public subnet and it is nearer to the internet gateway and all the things. It is not that much secure, even though it need to be accessed by the users and all the things, so that the ports are being compromised or something like that. Yep. This is the security group. I took ID from the security group, just accessing from it. The subnets. Here you can see we are using subnet 1, subnet 2. I think these are public subnets. Here you can see these are public subnets. Let's get into main.tf. See here. AWS subnet sub1, AWS subnet sub1 dot id, AWS subnet dot sub2 id. We are integrating this uh, public subnets to the load balancer so that the load balancer will be created in an application will be created in a public subnets rather than any subnets, private or something like that. Enable deletion process false. Absolutely, will not delete it. It is a load balancer. I gave a random name about it. Next thing is that creating the target group. It is important to create a target group to listen the, let's say, we need to create a target group to take the, what to say, we need to create the target group to listen to the instance. Let's say we created the auto scaling group. From that auto scaling group, this thing target this application load balancer is being accessed, so that it is important to create target groups. It is like mandatory thing when you are creating this application load balancer. Without that, you can't listen to the application. Here is a resource for it. The protocol is been HTTP because we did not integrate any TLS or uh, TLS or TLS certificates or something like that. If we integrate that, we can. In the future, I can if you want. Yep. This is a health check. Has health threshold equal to 5. Let's say you have two instances running, and if one instance is not running, you can see like in the dashboard, it is the unhealthy and one part is these are the conditions to satisfy those health check or something like that. And this is a life cycle create for destroy. As the application is running on port 80, will be using a listener on port 80. That's why this resource is being created. Here, if you see in the user data.sh, okay, fine. Absolutely. That is why we are creating this. This is run under port 80. That is why we are being user. And next thing is that I think you have understood about this. It's not a rocket science. If you want to understand about this, I think there are many tutorials about it. You can watch it because everything can't be explained here. Absolutely. That is why I'm not explaining too deep into it. Absolutely. These are pretty basic stuff. I think so. Yep. Next thing is that you need to have auto scaling groups in the private subnets. Here, if you see again, we have integrated auto scaling group in a private subnets, not public subnets. We have integrated load balancer in a public subnet so that ports are open and everything is done. But in a private subnet, we don't have any ports or open and all the things. That is why it is important to have this. Yep. Yep. First thing is that in the auto scaling group, as I said, like we'll be using customizable AMIs. We'll be using our own AMIs, right? That is why we are using this AMI, which is there, like already we produced in the part one of the project. Yep, if you see this, 1 minute, you see this. Yep, the same thing we integrated here. The same thing we integrated here in the auto scaling group so that it will use this customizable AMI, customized AMI, and it will launch an instance according to that. And next thing is that auto scaling group rolls up an instance, right? It need to just roll up an instance. That is the future of auto scaling group. So that we need to create an IAM role for auto scaling group. Autos in the in the IAM role, here is the EC2 full access and everything. This is the thing. We'll just full access. Here is the action on all the things. This is the thing. You can just copy paste if you want. If you want the this also I picked it from official documentation. Official documentation. There is no rocket science or something like that. And next thing is that Terraform AWS template launch will just use user data. Okay, this is good. You use it official customized AMI. This is good. On the top of it, you need to run this Docker file, right? We containerize the application in the part 2, I think so. We need to use this application. We need to use that Docker file and launch the instance. Launch the instance. This is the instance we are using T2 micro. Through this through this only we'll access this. This is like in the private subnet. Private subnet which is associated with NAT gateway and all the things. Private subnet means you can understand. Okay, there are no ports allowed to it. Okay, these are the thing like user data.sh. It will take user data from user.data.sh. I'll show you user data. First thing is that it will just, I'll show you. See, it will just create, sorry, it will update the packages. It will just install the Docker. It will Docker Compose. It will just install the Docker Compose. Will move some files to it and enable Docker service systemctl. Absolutely, it is good. And SSM will be used for troubleshooting kind of things. And absolutely, and we'll be using EC2 user and restart the Docker service. We'll pull the image and just run it, and this will be taken place in, like if you see here, there is a port 80 with the help of port 80 only will be accessed this. That is why it is important to have port 80 open in the not a port 80 open. Sorry, I'm talking about something. Okay, we'll just expose this port 80. uh, we'll just port map to port 80 to port 8080. That is the thing we do. And just we integrate with auto scaling group. That is the thing we do. Will not do any will not expose any port in the private subnets. It is not important to expose any ports in the private subnet. Rather than we export in the public subnet at an sorry, application load balancer thing. That is why I opened in the public subnets port 80. That is the thing, if you understand it. Absolutely, VPC security group IDs. This is the thing, like security group. I have created security group according to it. That is the thing we can use. And yep, in the security group also there is no port open, I think so. That is the thing. And next thing is that resource auto scaling group. We'll be creating the auto scaling. We have created the template, IAM role. We have fetched the data and all the things to just create the auto scaling group. Here, if you see desired capacity is one, you can create two instances if you want, but I kept as one. Absolutely, maximum size one, minimum size also one. Absolutely, force delete true. If you want to host delete, we can do it, and depends on application load balancer. Absolutely, this application load balancer you can just fetch the ID from here and just keep it here. Application load balancer. Absolutely, we need to connect the auto scaling group to the application load balancer. Here, if you see that auto scaling group is connected to auto scaling group is connected to application load balancer. That is the thing we are doing here. And target group, we just mention this target group at application load balancer. If you see here, sorry, target group. Yep, this is the target group. We'll just integrate to this auto scaling group. Yep, health check type is a tool if you want. Launch template, we are integrating this launch template out there. Launch template T2 micro and all the things. This is the thing. This is the thing. And next thing is that VPC identifier. If you want, you can uh, at where it is creating. Absolutely, we are creating in private subnets. Auto scaling group, we are creating in private subnets, right? Here, if you see again, auto scaling group is created in a sorry private subnets. Yep, in a private subnet. So we are using this private subnets. See, private subnet to ID. Yep. You can just give any key and value to it and propagate at launch. Whenever we do Terraform apply, uh, automatically it will create. That is the thing. Okay, we created two things. Okay, we created this part, total part, right? We also create secure subnets also. We need to just create this RDS kind of thing and just connect this to auto scaling group. That is only pending here. Let's do it. Okay, fine. Shit. Yes. Here, if you see, we are creating a security group for it. Absolutely, we need to create security group for it because port 3006 need to be there because it is a MySQL port. Absolutely, we will not integrate any route tables and all the things so that no worries for it. Just we are opening it for, not for public. This is like secure private subnet, so no worries in it. No worries, we are not integrating any 22 or something like that, port 22 or something like that. So no worries. Absolutely, we are integrating this subnet group. These are the subnet IDs. See, here we integrated two secure subnets. See here. So we are creating this RDS instance in a secure subnets where there are no route tables, where there are no route tables, so that no one can access this application using route table. It can access using only endpoints only. I'll talk about endpoints later. Okay, fine. This is the thing we are integrating with secure subnets. Next thing is that here, if you see, we are creating an instance, RDS instance. Here, if you see engine version and all these things, and this is the T2 micro instance, T2 micro instance. And here, if you see DB subnet name, we are just passing this values, subnet name. And next thing is that VPC group IDs. I mean to say uh, security group. Which security group? This security group as it act as port 3306 as open. That is the MySQL default port. Absolutely. Availability zone. AP South 1A, you can choose AP South 1B also, no problem. Skip final snapshot. Okay, fine. That is good. DB name pet clinic. That is the thing. Yep. This will just create an RDS endpoint. You may think like, how do you connect this thing, this RDS to this auto scaling group, right? Here is the thing. We just connect using RDS endpoint. Here, if you see MySQL URL, RDS db.instance, db instance dot endpoint. From this, we'll connect this RDS instance to the endpoint. That is the thing we connect. And here, if you see in the Docker run something like that, we'll just pass this value so that it will just uh, create an RDS instance so that it will be good, so that it will be visible to it, the application can be accessed. Okay, here is the architecture and we successfully completed this thing. We'll just terraform in it and terraform something like that. We'll just create an infrastructure using this terraform. Let's get into this file first. Let's here if you can see clear terraform init. Yes, terraform successfully initialized. Let's clear it. Terraform plan. Yeah, here if you see 39 resources to add, 0 to destroy. These are the resources to add. Auto scaling group, instance. This all the things. As I said, this all the things are important. Let's just do clear and again. Terraform plan. Yep, let's do yes. Oh shit, I again done Terraform plan. I need to do Terraform apply, sorry. Let's do yes. Here is the thing now creating. Let's wait. It will create in 3 minutes or 4 minutes kind of time. Let's wait. Up to that, let's create the EKS clusters for next part because EKS clusters take time. EKS add cluster create. You can create using Terraform also, but I don't want to create that because it will take time again. Let's create a Spring Pet Clinic. Absolutely 129. Yes, this is the latest version. Let's see if that created. I think I have to create the service role. I'll just go to IAM. Better is that if we create from terminal only. Let's wait for it. Just because there are many options in it. I never created through this, but let's create through terminal. Still creating. Yes. Better is that if we create that EKS cluster through terminal, I think so. Because it is the most preferred way. Because you have multiple options. Like these are the things and next again why do just just the click ops kind of thing. I don't want to do it. If you want to create using Terraform also good, but these things take time, like 15, 20 minutes. Like whole infrastructure using like if you mix up all the things using EKS and something like that, will take like these things take about 4 minutes of time, and EKS clusters will take about 15 minutes of time. That is why I didn't integrated EKS clusters. No worries. You want to integrate Argo City is also good. That is also good, but we I didn't integrate any Argo City because it's EKS clusters are pretty costly, and yep, pretty costly. I mean to say, EKS clusters are pretty costly, and it is a one-time process. I don't want to complicate all the things. That is why I integrate this auto scaling group. I'm sorry, this Argo CD, and it is creating the launch template and auto scaling group. Yep, think it's creating. Let's wait. Yep, yep. It is created successfully. We'll see if it is created successfully or not. Here, if you see, like there is one instance running, and again it need to be two instances. Yep, there's two instances running. T2 micro initializing. Let's see, load balancer kind of thing. It will take time because it is not a Kubernetes kind of thing, right? It will take time. It will take at least 1 minute of time to get this. Here is the thing, DNS. We'll just do in 1 minute or 2 minutes of time because initializing it not to be initialized, right? That is why I'm waiting it. Initializing. If it initialized, we can just it is just initializing. Okay, let's see this load. All the things are being created. Here, if you see auto scaling group in private activity and all the things successfully initialized. It is initializing again. Here's the load balancer. And next thing is that cluster database instance, right? Sorry, wait, is sorry, RDS, right? See here you can see database instance, pet clinic running successfully, AP South 1A. You can monitor using this. Yep. We'll see like if the instance is running, we can access through application load balancer. And if that initialization is success, yep, it is running and initialization got success. We'll just run, sorry, application load balancer, right? Load balancers. Where is this? DNS, yep. It will take time because, yep, successfully application got deployed. Absolutely. Yep. Here you can see everything. Database is also there. Let's say, okay, Deepak, ready. This is the thing. You can't find owner. Let's add the owner. Let's say, okay, we'll just add owner like anything, something like that. Don't call to this number. Just a random number. Just a random address. Okay. Numeric. Yep. This is also there. Huh? I haven't thought. 3, 4, 5, 6. 5, 6, 7, 8, 9, 10. This is a thing. And add new pet. Just a random name. Just a random birth or something like that. Yep. Bird. Yes. Yep. This is the thing. And just let's go back and let's ready. Find owner. You can see the database is also working fine. Everything is working fine. The application is working fine. Everything. You can see everything. This is the thing. Absolutely. This is not final thing, but you can say like mid 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 of it. We are in mid of it. Absolutely. This is the thing. Okay. Let's destroy it because AWS will charge for us. We need to destroy it. Let's destroy the things. It will not destroy the AWS S3, which are created in an remote backends. It will just destroy all the things. It will not destroy, I think so. VPC and this S3 because of some things. Yep, it will destroy all the things. This is the thing. We integrated, no problems. This is the what to say? This is the beauty of Terraform because you can in a one command you can create the infrastructure, in one command you can destroy the infrastructure. That is the main thing of it. I think this is good. We'll go to part 4. I think it will not delete the VPC because it has associated with the subnet group. Sorry, uh, those are security groups, and it will not delete the remote backend, which is S3 bucket. It is destroying all the things. Yep, I have all the repository links. You can see it. Spirit Clinic, Spring Up. These are the things. These are 4 parts. I have many things also. Okay. You can follow me if you want. This is the next part. Like we have all the things. To that, let's create a, I think we'll create here only. This approach is also good, but you can use modular approach. Modular approach is always better than always, better than all the approaches. I think there is a command for AWS. I forgot that. I don't know. AWS EKS creation using Fargate. I forgot the command by CLI, AWS CLI. I need to see it. See, I'll also follow this something documentation. We are not any something like that. Ah, yes, I need to install this EKSCTL, right? EKSCTL installation. Yep, you can refer official logs. Yep, Unix. Okay, let's configure in my Minikube. Create cluster and something like that. It'll take like 10 to 15 to 25 minutes. That is why first we need to install this EKSCTL. I think it is done. No, no, it is not done. It is, this is frustrating somewhat. Okay. I think we'll create another, what to say, another terminal. Better is that I'm using WSL. Okay, let's create using this EC2 instance only. Why to worry? Again, I need to that configure. I'm pretty lazy. Okay, fine. We'll do it. Yep, running. Connect. Just connect using this. First, I need to configure distance. I think I have it. Yep, secret credentials. I'll delete this after this. No worries. I understand. Okay, fine. AWS. Okay, I didn't install AWS CLI only. Let's install it. I'm installing her on this one. Okay. Okay, let's go to official documentation. Okay, here is official docs. I think, yep, it is still destroying. That's why I choose that. It is installing AWS CLI. Oh, still it is destroying. Okay, I think VPC will not be destroyed because it is dependent. Absolutely, I said right. It has dependencies. That's why it will not destroy. And S3 is like remote backend, so it will not destroy it. These are the things. I think we can create using this. I think so. We can create. That is good. That's good. I need to install this EKCTL, right? It's taking time. Okay. Oh, so many logs. Yep, clear will run AWS version to get the yep AWS CLI is successfully installed. Next thing is that installing this EKSCTL. Okay, fine. We install the EKSCTL. Let's see KSCTL. Okay, EKSCTL is successfully installed. And next thing is that we need to configure AWS configure. Yep. Access. I'll delete after this. No worries. I know. Absolutely. I'll delete this. No worries. Default region EP South 1 JSON. Yep. We have successfully configured it. You can see AWS S3LS. Here you can see the S3 bucket is there. It is listing out the S3 buckets. Let's clear it out. Okay, next thing is that, as you know, we are just configuring this EKSCTL thing. Let's copy and okay, cluster name equal to, we'll modify the name. I'll not keep that name only. Pet clinic EKS thing will use camel case in cutting. Oh shit. Regular pattern. Okay. What is the regular pattern? We'll just create with this name only. Okay. Okay, it is creating. It will take at least 15 minutes of time. I'm pausing this recording. No worries. Okay, after that, I'll explain this thing. With clinic part 4, manifest, service.yaml. Okay, I'll explain the deployment. Where is the deployment here? This is the deployment. Here, if you see, the name is pet clinic and selectors, which is being used at here at a service, so that selector matches and such that this service is configured. And yes, the replica is one. I don't want any like fancy replicas like 5 or 6. I want only replica one. And the name is pet clinic and the image is pulling from Deepak. That thing. You can use any image if you want. And next thing is that we'll store the ports, like all the ports and these things at config map. From config map it fetches the MySQL URL. From config map it fetches the key, it fetches the user, fetches all the password kind of things. Here if you see at the config map, there is user, database, URL. And the password is there in secret. Here if you see secrets here, you can see root is a password and pet clinic is the MySQL password. Root password is the root and MySQL normal password is pet clinic and type is opaque. You already know this. I think so. And we are creating two services, just normal one and for MySQL. For a MySQL, we are creating one more service and this is a MySQL service. As I said, we'll fetch this information from config map and secrets, so that it will be good approach. And the default port of the MySQL is 3036. As I said in the Terraform part 3 also, we integrated security group. There we open this 3036 port, 3306 port. That is the thing. MySQL has a default port of 3036, 3306. Sorry. That is the thing. We are integrating PVC, which is persistent storage, volume storage, also to this because we are dealing with this databases. It is highly important to have PVC kind of thing, which is like persistent volume claim. Here you can say the selectors and labels. We we need to be make sure that the selectors and labels should be like same in the service also, so that it matches and just clubs up and just uh, create a proper service. And the access nodes is read write once. This is 1 GB storage. This is the thing. And we are using EBS volumes for it. Here, if you see, like EBS volumes are there to store the PVC persistent volume claims. This is the thing of the Kubernetes deployment, Kubernetes part 4. It's pretty easy. It's not like a rocket science or complete thing. I have also done from this official documentations only. No worries. I think it is creating. Yep, it is creating. I think it will create around like 10 to 15 minutes. Hey guys, let's resume from where we stopped. Uh, we'll see like how do you deploy all the things. Let's resume it. Okay, share the screen. Yep. I have successfully created the EKS cluster. Let's see it. 1 minute. It's loading. Here, if you see, the EKS cluster is in active state and everything is there. We have configured the node group rather than the Fargates because I'm facing some issues with the Fargate. I deleted the Fargate profile here and created one node group. There is some issue with the Fargate profiles. Fargate has somewhat limitations because they are serverless nodes. So that we created something like node group. In this, T3 medium is running. If you can see here, EC2 instances. If you can see here, T3 medium is running. T3 medium is running, which is node group, which is the node group of the, node of the EKS cluster. EKS cluster. This is the thing. See here, EKS node version, something like that. Yep, that is the thing. Let's deploy our application in it. See here, like, let's see what are there. First thing is that we need to deploy the deployment kubectl apply minus f deploy dot yaml. If deployment has been created, let's check it. Get deploy. Here you can see pet clinic is there and it is up to date one to one. And you can see if you want to see what pods, kubectl get pods. Yes, the pet clinic is running. Let's deploy this service. Kubectl apply minus of service dot yaml. Absolutely, service also got created. The service will give a load balancer link. We'll just access the application using that load balancer link. Let's see if the service is load balancer link is appearing or not. Absolutely, you can see the load balancer link. Load balancer. Let's wait for just configuring this all the things because load balancer need to be created so that these things it will take time to create the load balancer and attach this all these things. Let's wait for minimum of 30 seconds or something like that. I copied the link. Let's paste it out if that is working. Yep, the link is working and load balancer is also working. Public load balancer, ELB, AWS. Let's see if the database is also working. Like we integrated MySQL database to it. Absolutely. This is the Kubernetes deployment. And earlier one is that with the help of AWS, what to say, architecture, that architecture, we deployed the things. Let's see if the, okay, let's add the owner. Okay, not same thing. Let's just random name, random things. Let's go with 1, 2, 3, 4, 5, 5, 6, 7, 8, 9, 1. Yep, this owner is created. This is let's search with CK afterwards. Okay, this is the thing, and just find owners. Just type CK. See, find owner. You can find this owner. This is the thing. The application is working fine. The database is working fine, and these things are working fine. You can see everything. I think so. We done two deployments. First one is with the help of Terraform, we deployed an application and done that architecture. And now we deployed this in a Kubernetes. Using the Kubernetes, a load balancer has been created. If you know the service types, there are three service types. First one is that you have default cluster IP mode. Second thing is that node IP mode. With the node IP mode, you can just access in your within your node range. But you if you want to expose this application to outside world, there is need of public load balancer. That is why we created a service called public load balancer that is being created and being used. This is the final deployment and we successfully completed our project. Absolutely, absolutely, this is a very good project if you want to showcase in your resume or something like that. uh, Absolutely, you can tag me and DevOps Cloud Labs for this effort. And as I promised, also like I need to destroy these things. Okay, fine. Let's destroy this EKS cluster first. We can destroy through UA also. There is no problem, I think so. But you need to destroy in this cloud formation template also, because if you destroy in this only, in the cloud formation template, it will be like it is same like Terraform state file, so that we need to delete there also. Just I will delete this cluster first. I need to delete the node group, I think so. Here is the node group. Let's delete this node group. This is the thing. Let's okay, this node group will take time. I think so. Deletion will take time. After that, we will just delete this EKS cluster directly. There is no problem. And let's not forget about cloud formation templates. Sorry, cloud formation. Cloud formation. Yep. If we go into this, here also you need to delete the EKS cluster cutting. After deletion of EKS cluster, see here the information is stored like the state file, same like the state file. So that we need to delete. Here is the application. You can see that we need to delete this also to get into. Let's close this. Okay, fine. This is the thing. I think I have opened this thing now. Load balancer thing. Sorry. Here's clusters. Sorry, cloud formation. Formation. Sorry, here, right? Okay, fine. I forgot to switch the tabs. No problem. I think so. Yep. Here is the thing. We need to delete this also to ensure that no cost or something like that affects. This is the thing. I think so. You have understood this total project end to end. This is the total project end to end. I'll also explain like if you want this thing like uh, how to explain this project in an interview. Wait a few minutes, like in 2 minutes or something like that. I'll explain this. Yeah. I'll get into Canva. This is the thing. Okay. For now, I'll explain this project. Okay. This is very important because this is the most important thing for your resume or career building or something like that. If you don't listen all the product also, no problem, listen this. Okay, that is why I kept at last this thing. If you want, I can put this video separate. There is no problem for me. Okay, let's start. Okay, this project, how could you explain as a freelance project? I'll explain like that. Let's say a interviewer asked me like explain the architecture and all the things in one go. Okay, I'll explain that. Hey, we created a project based on a freelancing client. A freelancing client gave us this architecture to implement. He told that the best practices need to be implemented. Best practices need to be implemented, and we took take care of all the best practices like storing the Terraform state file in S3 buckets, which is called remote backends, and something like DynamoDB lock key in the DynamoDB, and something like using of Fargates, which is suitable for cost optimization of EKS clusters, uh, and something like using of GitHub webhooks, which are like great things to resource management of the Jenkins, and all the things are being covered in this in this project, which are best approaches. I feel that, and we also use it best approaches like in the Kubernetes part. We also use it RBACs and security policies, network policies to configure all the resources. These are the things we use it in the project. Let's get into part by part. There are four parts in this project. First part is the generation of AMI using Packer, custom AMI using Packer. We generated one custom AMI using Packer so that we can use this AMI at another state like auto scaling group, and load balancer kind of thing, so that the downtime is very less due to this AMI, custom AMI. Due to this custom AMI, at a part one, we created this custom AMI using Packer, which is configured with Jenkins, so that without manual intervention, so that automation can take place at a pipeline level. That is the first part. And second part is that we integrated some of the DevSecOps tools like Snyk, Sonar Cloud in a Jenkins pipeline too, so that so that application vulnerabilities can be identified and Jira ticket can be raised according to that. At a first stage, we just scanned using Snyk and Sonar Cloud so that vulnerabilities can be identified and report can be generated using that. And in the second thing, we used Maven to build the package as it is a Java application, so that a jar file is generated using the Maven. We used Maven clean package, the command of it, and using that jar file, we built a docker file around it. And next thing is that we integrated Trivy to scan the vulnerabilities in the docker file, so that vulnerabilities can be identified, and our developer team can raise a Jira ticket or something like that. We raised a Jira ticket according to these vulnerabilities. And next thing is that we didn't directly push this jar file to the Docker Hub. We push this jar file to the JFrog because it is the industry grade tool which is being used, and JFrog has something like X-rays at which jar files are scanned for vulnerabilities. This is the thing. And next thing is that we just pushed this Docker file to Docker Hub using Docker push command. That is the thing we used in done in the second pipeline. We used some of the best approaches here also, like DevSecOps approach and something like Maven thing. This and JFrog thing. These are like industry grade tools which are being used. So according to the client requirement, we need to use best approaches, so that we use these all the things, and these are very pretty secure. These approaches make our application pretty secure. And next part is that we used something like Terraform to create this whole infrastructure according as the client require best approaches. Terraform is the best approach to create this infrastructure, as we can in a one command we can just create the infrastructure, and in one command we can just destroy the infrastructure. That is the beauty of Terraform. Due to that advantages, we created in a whole infrastructure using Terraform. In this infrastructure, we use modules like Terraform modules which are reusable, as my sense, like Terraform modules which can be reusable. Like, let's say if we wrote the whole project in a Terraform modules, we can reuse this project, these whole things afterwards also. That's the whole idea of this using of modules. And next thing is that coming to architecture part here, if you can see, like we created an a VPC. There are two availability zones. This is the most efficient way to create an architecture, so that if one goes down, other is also there. In an VPC, we have something like something like three-tier architecture. Three-tier architecture. In a three-tier architecture, we have two public subnets, two private subnets, and two secure subnets as well. In the public subnet, we have created NAT gateways and application load balancer. As application load balancer is a final thing which can be accessed by the user, and we also integrated route 53 with the application load balancer DNS link, so that users can access efficiently. And in the public subnet, we have created application load balancer so that users can access. In public subnet, we have NAT gateways also associated. NAT gateways are directly associated with internet gateways so that they can mask the IP address. This is a security approach taken for the masking of IP address. Next thing is that we integrated route tables towards it from public subnet to internet gateway. That is the route table. And next comes with private subnet. In a private subnet, there are two private subnets. In the two private subnets, we created something like auto scaling group, which is like auto scaling group, which rolls up an instance with all the user data provided to it, so that it will just it will just pull the containerized application. So what to say? It will just pull the Docker from the Docker hub, so that it will just run in an instance. And we are using user data in this auto scaling group, apart from using AMI also, the golden AMI which was created in the part 1. Absolutely, this is the thing. And we are associating the route tables to this NAT gateways through the private subnet. There are two route tables associated to this NAT gateways, individual route tables associated to it. And next thing is that we are creating something new kind of thing, which is secure subnet. In this secure subnet, there is no route table, no ports open, no things. Like, we have no security group. I think we have security group, but we don't have any route table towards it. We just connect the auto scaling group to this RDS instance through RDS endpoint. That is the thing. There is no route table associated to it. We made this subnet very secure, pretty secure, because this is the thing hackers can hack, so that if the database is breached, total organization will come into loss. That is why we didn't take any step like integrating any route tables. We just connect using RDS endpoint. That is the thing for it. So in the secure subnet, we'll just access using application load balancer. This is the thing. And next thing is that part 4 comes with Kubernetes deployments. We have integrated Argo CD, which is a continuous deployment tool, so that automation takes place at that thing. And next thing is that in this Kubernetes thing, we integrated all the service. We have two services mainly. First thing is that application and database also. We have application ka service and database ka service. These two services run at a time, and we have something like config maps and secrets too. We have persistent volume claims to get the volumes for the database, so that MySQL database runs securely and efficiently. That is the thing we integrated. And we have integrated all these things in an EKS clusters. We have not used Fargates due to some other reason, because Fargates are not compatible for this PVC, persistent volume claims. Fargates have somewhat disadvantages regarding this, so that we use it node groups, which is T3 medium kind of thing, which are that is the thing we use it in the Kubernetes deployments. Yes. Okay, fine. This is the thing we integrated all the things, and we have monitored using CloudWatch, CloudWatch logs. And if we want to troubleshoot these things, we have SSM, AWS Systems Manager. Using AWS Systems Manager, we can troubleshoot this instance out there. This is the thing. Okay, fine. We can. I think this is good. I have just explained this thing, all the thing, to an interviewer who is present there. Yep, like it. If you like this, all the things, like I have this for this project, it took me like 15 to 20 days. It is lot of effort putting for this project for you guys. And like this project and share with your friends. Share with your friends, Pakka, for sure. Because this is a very good project if you could explain in your resume or something like that. Absolutely. This is good.